In this video, we're going to go over solution concentration, parts per million or ppm, and parts per billion, ppb. So parts per million and parts per billion are concentrations of very dilute solutions. They are low or trace levels of chemicals. An example of when you would use ppm or ppb is when you're talking about an allowable level of mercury in fish for human consumption. It is 1 part per million is the allowable level of mercury in fish. So for concentration, we can see here that 1 gram per milliliter, or we have 0.0000001 gram per milliliter is the mass volume concentration. The percent mass volume concentration is 0.00001%. Part per million, it's equal to 0.1 part per million. It's part per billion is equal to 100 parts per billion. So the parts per million, parts per billion unit or concentration helps to avoid the many zeros before the decimal that would otherwise result in a very dilute solution, where if it was reported in the percent mass per volume or just mass per volume. Another example of parts per million is the allowable level of arsenic in water for human consumption, which is 10 parts per billion. So calculations for parts per billion and parts per million. So parts per 100 is just a percent, okay, which is mass of a compound over total mass or volume of a mixture times 100 is what you would think of as a percent at its parts per 100. If you multiply the mass of a compound over total mass or volume of a mixture by 1 million or 1 times 10 to the 6th, you get parts per million. If you multiply it by 1 billion or 1 times 10 to the 9th, so there's 9 zeros here, 1, 2, 3, 4, 5, 6, 7, 8, 9, you get parts per billion. So that's how you get the ppm and ppb. So to practice, the EPA maximum allowable concentration of lead in drinking water is 5 parts per billion. Express this concentration in grams per milliliter, which is mass volume concentration, and percent mass volume, and parts per million. So pause the video, work on this, and we'll come back. Okay, so if we have 5 parts per billion, this is equal to 5 times 10 to the negative 9th grams per milliliter, because billion is 10 to the 9th. As we saw in the equation before, you'd have your total mass of the solute over the total mass of the solution or volume of the solution times 10 to the 9th to get the parts per billion. So this would be the mass volume. The percent mass volume would be your mass volume times 100 would be your percent mass volume. So this one would equal 5 times 10 to the negative 7th. Parts per million. So if we have 5 parts per billion, 5 parts, and we want it parts per million, parts per million is 10 to the 6th power, right? And so we know that this is our mass volume. Our equation for parts per million is our mass volume, 5 times 10 to the negative 9th times 1 times 10 to the 6th. So this will equal 5 times 10 to the negative 3rd parts per million. So this is our equation from right here. We have this whole part right here is mass volume. We have 1 times 10 to the ninth parts per million, 1 times 10 to the sixth is parts per million. So I multiplied our mass volume times 1 times 10 to the sixth. We get 5 times 10 to the negative third parts per million. So in summary, parts per million and parts per billion are concentrations of very dilute solutions. To compare mass volume, percent mass volume, parts per million, parts per billion, first convert them parts per billion or parts per million to a mass volume concentration, and then substitute that value into the appropriate parts per million, parts per billion, percent mass volume equation.